The results of the 2018 Water Olympic events are in. I'm Anthony Mendoza. Event 1. The universal solvent tested the ability to dissolve salt. A pinch of salt was dropped into beaker A, which contained 100 milliliters of water, and was stirred vigorously for 1 minute. Water's polarity was on full display. The positive hydrogen attracted the negative chloride ions, and the negative oxygen attracted the positive sodium ions, successfully dissolving the pinch of sodium chloride. Beaker B, which contained 100 milliliters of oil, already had salt in it, and was also stirred vigorously for 1 minute. Because salt is polar and oil is nonpolar, the molecules were not attracted to each other, leaving sodium chloride's ionic bonds intact. Event 2. Drops on a penny tested the property of molecules sticking together. 3 liquids were placed on a penny drop by drop until the penny could fit no more and the liquid eventually overflowed. Averages go as follows. Alcohol, 10 drops. Water, 25 drops. Soapy water, 15 drops. The secret to water success? Cohesion. Water molecules' advantage is the positive and negative charges of hydrogen and oxygen that make up H2O. The polar nature of water gives it maximum stickiness and clumpability. Event 3. Floating a paperclip experimented with water's density. Using a fork and a steady hand, a paperclip was rested on the surface of water where it promptly sunk. The same stunt was tried again, but this time there was salt in the water. The paperclip floated. Yippee! The salt in the water dissolved, adding to the water's mass, making it more dense. The paperclip was then less dense than the salt water, allowing it to float. Yay! Event 4. Density differences continued to experiment with water's density. A graduated cylinder was crammed with 10 milliliters of corn syrup, 10 milliliters of red-colored water, 10 milliliters of vegetable oil, and finally, 10 milliliters of blue isopropyl alcohol. The mouth of the graduated cylinder was securely covered with paraffin and inverted 3 times. At first the liquids mixed, but after a minute of sitting, the less dense liquids realized that they were lighter than the more dense liquids and floated on top of the heavier liquids. Event 5. Climbing water displayed water's attraction to other molecules. The tip of a strip of a paper towel was placed in 10 milliliters of water within a graduated cylinder. After 3.7 minutes, the water had climbed around 25 millimeters of paper towel strip. This phenomenon occurred due to adhesion. This is because the water molecules are attracted to the charged glass walls of the graduated cylinder more than they were to each other, resulting in the 25 millimeter hike. This type of adhesion is called capillary action. Event 6. Milk rainbow painted polarity in an explosive way. Drops of food coloring were added to a paper plate filled with 50 milliliters of milk. The resulting sludge of color was then touched with a clean cotton swab. There was no reaction. The cotton swab was then dipped and soaked, and the milk was touched again. This time there was a pretty explosion of colors. Ooh. Ah. The soap, like water, has a polar and nonpolar surface. The polar surface is attracted to the water, and the nonpolar surface is attracted to the fat in the milk. The nonpolar fat within the milk moves in mysterious ways, and thanks to the food coloring molecules being thrust about, we can now see the motion in the ocean. Event 7. Ice and cool was omitted from the 2018 Water Olympic events because the ice provided was very silly. Event 8. Celebration celebrates with even more capillary action. Woo! A cut end of celery was placed in 100 milliliters of colored water. After 50 minutes, it was removed from the water and appeared the same, but the inside was a different story. The water molecules were more attracted to the xylem walls of the celery than they were to each other, resulting in the water adhering to it. The tainted water and the process of capillary action highlighted the xylem with color. Event 9. Water phase diagram demonstrated the heat curve of water and its specific heat. Specific heat is defined as the amount of heat 1 gram of a substance must absorb to lose or change its temperature by 1 degree Celsius. For water, this amount is 4.184 joules. As a result, it takes water a long time to heat and a long time to cool. This property can be seen on the graph. The water stays in liquid form through a range of 0 to 100 degrees Celsius for 26 minutes. That concludes the 2018 Water Olympic events. But before I go, I'd like to leave you with today's bonus water property from Chris.
When water freezes, the water molecules form a hollow crystalline structure because there was not enough energy to break water's hydrogen bonds. This makes ice less dense than liquid water and allows it to float at the surface of liquid water. In ponds, for example, ice forms on their surface, which creates an insulating barrier that protects the animals and plant life in the pond from freezing. Thus, it allows those plants and animals who live in the pond to survive. They won't be frozen in a solid block of ice.
Thank you, Chris. And on that note, we end the recap of the 2018 Water Olympics. Here's to many more. Whoop! I'm Anthony Mendoza. Thanks for watching.